Hello everybody, welcome. This is paper 1 from November 2023, time zone 1. Let's work through this and see what we can do. Question 7. Alright. An athlete on a horizontal athletic field throws a discus. The height of the discus above the field in meters after it is thrown can be modeled using a quadratic function of the form f of x is equal to ax squared plus bx plus c, where x represents the horizontal distance in meters that the discus has traveled from the athlete. A specialized camera tracks the initial path of the discus after it is thrown by the athlete. The camera records that the discus travels through 3 points, 3, 282, 6, 4.25, and 9, 5.30, as shown in diagram 1. Use the coordinates 3, 2.82 to write down an equation of a, b, and c. So write down an equation in terms of a, b, and c. So what are they asking us? They're asking us for an equation, something with some equivalent sign, and they want us to write it down in terms of a, b, and c. The IB will rarely give information that isn't useful. They'll tell you about, like, let's say when the pyramids were built and so on, but after that they won't give you like inessential reading. So this first part, they told us that the height of the discus can be modeled by some quadratic of the form ax squared plus bx plus c. So we have this form of f of x, which is our output, is equal to ax squared plus bx plus c. And f of x, what is f of x? The height, right? So we can essentially almost call this h. F of x is our output, but the output itself is height. So we can almost call this the height. And we have these coordinate points. So we know after the discus has traveled a horizontal distance of 3, it's 2.82 meters in the air. And it's traveled a distance of 6, it's 4.25 meters in the air, and so on. So let's input these values into this function that they give us, and then we will have an equation in terms of a, b, and c. So an equation in terms of these variables a, b, and c, we see them in this quadratic, so let's input and we'll get an equation in terms of a, b, and c. So height is equal to 2.82, and then a, we don't know what it is, but we know that the horizontal distance is 3 squared, or yeah, let's write it as 9 right away. So let's write it as 3 squared, plus b times 3 plus c. So now we actually have an equation in terms of a, b, and c. So this is one equation in terms of a, b, and c. There it is. One more question. Use your answer to part A and 2 similar equations to find the equation of the quadratic model for the height of the discus. Not a fan of this question, to be honest, because I think they are in some sense shoehorning or pigeonholing in some sense the test taker to solve it in a certain way, which actually I don't think is the most efficient way. So as a mathematician, if you're given some problem and you have a set of tools that you can use to solve a problem, you would probably want to use the most efficient way to solve it. And here they're asking, okay, well, write it out in a way that isn't actually necessarily the most efficient way to go about this. I'm not a big fan of that, but can save the complaints, I suppose. All right. So if we could do the first one and write an equation in terms of a, b, and c, we want to do this again 2 more times using these 2 other points, and then we want to use not polynomial root solver, simultaneous equations. We want to use simultaneous equations to solve. So let's go ahead and do that. So here's equation 1. Let's go ahead and find equation 2. Substitute these values. We know the horizontal height is 4.25 plus, and then we're going to have a times 4.25 squared plus 3 times b times 4.25 plus c, and then we can square that. 4.25 squared, let's write it out. 4.25 equals, this is going to be it's 18.0625. Decimals, we might want to preserve all of our decimals in this case, but let's write it out as 3 sig figs. 4.25 plus C. And the last one for number 3 is going to make use of 5.30 is equal to, and in this case we're going to be having A 9 squared plus B plus C. 5.30 is equal to 81A plus 9B plus C. So we've got these 3 equations. And now, with those 3 equations, we can use it to find the values of A, B, and C. So our function is given in terms of a quadratic, and this is the standard form of a quadratic, ax squared plus bx plus c. And if we know these values of A, B, and C, then we can fill in and find the equation of a quadratic. It's a similar sense to our equation of a line as y equals mx plus b. If we know m and b, then we have all we need in terms of the ingredients for an equation of a line. Here for a quadratic, it's just a, b, and c. And so how do we do this? I'm actually going to show you the easier way first. I'm going to show you the easier way. So this is a 3-mark question. It's an 8-mark question altogether. Actually, sorry, a 9-mark question. So you can potentially solve this using linear equations, simultaneous equations, but I'll show you an easier way to actually solve this. Okay, so let's go ahead back to the calculator screen. If we go into spreadsheets and we write our x values, our horizontal distance, and our y values, or the height, and let's put in the values that they give us. 3 and 2.82, 6 and 4.25, and 9 and 5.30. We have those values for horizontal distance and height. Just like we need 2 values to find an equation of a line, we need 3 values to find a quadratic. So now we've got our values. Let's go statistics, stat calculations. Just like we did linear regression in the past, here we've got a quadratic. Our x's are in our x, our y's are in our y's, and there it is, A, B, and C. This is our quadratic. So I'm going to write this down. Where can we write it? To find the equation of the quadratic model for the height, I'll write it here. Y is equal to negative 0.0211. Make sure there's nothing else. 2111. That's right. X squared plus 0.667x plus 1.01. All right, there we go. Let's solve it how they would like to. Actually, use your answer in part A and 2 similar equations to find the equation of the quadratic model. So they're actually, if we have these 2 equations, to be honest, looking at the document once again, if we've got this first equation, the second equation, third equation, that's all they're asking us to do. And then they're asking us to find the model. I think that is actually the most straightforward and easiest way to find the model. But I'll show you how they would like you to solve it in a sense. What they're asking you to do, so far as I see, is they're asking you to solve a system of linear equations. So going back to the calculator, if we're at the home screen, menu, algebra, solve a system of linear equations. We have 3 equations in terms of x and y, and then we can put them in. That is to say, we have 2.82 is equal to 9x rather. This is a, b, and c. So 9x plus 3b plus, oops, I shouldn't do that, plus z. And to be honest, if you want to skip ahead, you can. I don't actually recommend you taking this path. X plus 4.25 y plus z, and then let's see, 5.3 is equal to 81x plus 9y. I just think there's a lot of ways that this can potentially go wrong. 2.82, 9x plus 3y, that's good. 18.1, 4.25 c, 5.3, okay. 2.82, 18.1, 81, x, y plus z. To be honest, I'll have to see. Let's see. So, here we go. This is me using a set of simultaneous equations, and to be honest, I've made some mistake here. The question using the first method of spreadsheets, just looking at the mark scheme, is given the correct answer. There's been some kind of input incorrect in here, and I can't say I'm particularly keen to try to figure out where. I don't think this is the most efficient way to solve this, and I'd recommend that you don't do it this way. But I guess maybe the one thing that's potentially helpful is linear equation solver, which you don't actually need to use too often, I don't think. I think spreadsheets is often a more efficient way. Okay, let's go back to the document itself. Okay. A 1.8 meter high wall is 30 meters from where the athlete threw the discus, as shown in diagram 2. Show that the model predicts that the discus will go over the wall. Find the horizontal distance that the discus will travel from the athlete until it first hits the ground, according to this model. Okay, so our model itself gives us a relationship between the height of the discus and the horizontal distance. So show that the model predicts that the discus will go over the wall. So we want to ensure that when we are 30 meters away, we're at least 1.8 meters high. So let's actually find the height when we are 30 meters away. So negative 0.0211, and this should be 30 squared plus 0.667, and this again should be 30. And this should be plus 1.01. Let's go ahead and work this out. 30 squared times negative 0.0211 plus 0.667 times 30 plus 1.01. And I've got a height of 2.03. Okay, show that the model predicts the discus will go over the wall. Really nice 3-mark question. Geez, that's just a pretty simple input-output question for 3 marks. I guess it hangs on whether the model itself was correct. Alright, find the horizontal distance that the discus will travel from the athlete until it first hits the ground. Again, we've got an input-output model, pretty generous 2 marks. It depends on whether we've got the model correct. Here it is. So, find the horizontal distance, that is to say the value of x, where the horizontal distance traveled until it hits the ground. We know when it hits the ground. We know that h is going to be equal to 0, because there's no height. So let's go ahead and put an output for 0. And then negative 0.0211, and then this is going to be x squared. We want to find the values of x that are going to make this true. Plus 1.01. You can n-solve this, but the thing is when you do n-solve, it will give you the value that is closest to 0, so it'll actually give you a negative value, which would be incorrect because it's before time, really. So 2 ways to do this: potentially graph it, and that would be okay. Or you can use nsolve and just feed it in a value after 1. Feed it, let's say, 1 or 5, and it will find the value to the further right. But I'm going to go ahead and graph it because I think that's a nice visual way to go about doing this. So, home screen, once again, negative 0.0211 x squared plus 0.667x plus 1.01. Alright, that looks good. Let's graph it. Zoom out. Here we are. And then let's find, I'm going to analyze graph and find the 0. So at 33.1 meters, let's go back to the document. X is equal to 33.1 meters. When x is equal to 33.1 meters, we have reached the ground, which is good because it corresponds with this graph that they've given us, which is always nice, which is always reassuring. It means this extra little bit is 3.1 meters, and that looks about right. I mean, if it was 40 or 60 meters, tell us that something's maybe gone wrong. Alright, not a bad question, but the first quadratic question, or finding this as an equation in terms of a, b, and c, this was quite challenging. This is just spreadsheets. Linear regression, you need 2 values to constrain, 2 points to constrain a line. For quadratic, you need 1, 2, 3 points. So essentially you need a little more for quadratic, 3 points, and so on. Alright everybody, I hope that was helpful, and as always, best of luck. Take care.